Now, the only reason I'm actually looking at this is to show you why we don't use graph to actually try to estimate partial derivatives. If you look at this, I believe the positive y-axis is actually out this way. I think the negative x-axis is out this way. It's hard to actually get it to actually graph both points at both axes and label them at the same time. Meanwhile, I can try to pick a point. Let's say this one right here. I'll try to leave the cursor right there and just describe what do I think about the partial derivative with respect to x and the partial derivative with respect to y. Well, to do the partial derivative with respect to x, what I'm supposed to do is walk in a positive x direction and see what happens to z. Well, I think if you actually start at that point and start walking in a positive x direction, you're going to see something like this. And it looks like the slope is actually very positive. If someone said, how positive? I can't tell you. It's hard to get units on anything. If someone said, at this point, what can I say about the partial derivative with respect to y? Well, I'm supposed to walk along the graph parallel to the positive x-axis, parallel to the positive y-axis. Here's the positive y-axis, so I would actually start at this point, and I would start walking like this as I'm walking parallel to the y-axis. I can say, for example, that I think at that point, the partial derivative with respect to y is negative. So I walk in a positive x direction, the slope of the graph is positive. So the partial derivative with respect to x is positive. As I walk parallel to the positive y-axis, you can see that the z values are decreasing, so the partial derivative with respect to z would be negative. But how positive and how negative is an absolute miserable endeavor, and we're not going to try ever to try to estimate the slopes of the tangent lines in those directions using a graph. And this is exactly why.